Welcome to our project for EPD342, designed for manufacture and tooling. In this video, we present our solution to a common fabrication challenge, the Fishmouth pipe notching tooling system. Designed, fabricated, and tested entirely by our team, this tool aims to improve accuracy, efficiency, and repeatability in pipe joining applications. Our team consists of 4 members. Jie Ying is the leader and CAD expert. Amin is the costing expert. Zhen Choong is in charge of the mini project. And Nisa is the fabrication expert. Did you know, traditional pipe notching often causes poor fit, rough edges, and material waste. Methods like grinding or hole saws are slow and inconsistent. In this video, we'll show the problem we solved, how our tool works, and why it matters. Conventional pipe notching has many problems: poor notch quality, high waste, and low efficiency. Manual methods rely on skill and often cause errors in assembly. Without a proper tool, it's hard to get repeatable and high-quality results. We validated our design using SolidWorks. Motion studies confirmed smooth punch movement and correct alignment. A 0.5mm die clearance was set to ensure clean notching with minimal wear. The punch and die were aligned inside the housing, and a spring mechanism was added for vertical motion. All components were secured and tested for smooth operation and safety. We began by cutting tool steel blocks using a bandsaw. Next, the blocks were squared using a milling machine to ensure accurate reference surfaces. Then, CNC milling was used to machine the punch holder with precise slots and holes. After that, EDM wire cutting was applied to shape the punch key and the die. Heat treatment and hardness testing followed to ensure component strength and durability. Finally, the completed tool was evaluated and approved by Associate Professor IR, Dr. Ahmad Baharuddin bin Abdullah. This is our completed Fishmouth pipe notching tool. It's fully assembled, tested, and integrated with a smart monitoring system. The Arduino-based setup tracks punch temperature and vibration in real time, helping prevent wear and ensuring safer, more efficient operation. We sincerely appreciate Associate Professor IR, Dr. Ahmad Baharuddin bin Abdullah for evaluating our tool, and Associate Professor Dr. Mod Salman bin Abu Mansur for his continuous guidance throughout this project. That's all for EPD342 project video. Thank you for watching and supporting our work.